Hi everyone, my name is Tommy Andersson, and I am super happy to present at this conference, and I am very thankful to the organizers for inviting me. Let me start by apologizing. So I apologize that I cannot be with you today. I have to attend another important meeting, and I also informed the organizers about this when they sent me the invitation to present here. So it's not that I decided in the last minute that I couldn't join you. I knew already from the very beginning that I couldn't join. The second thing I would like to apologize for is that I'm normally known as a reasonably good presenter, but this online Zoom thing, that's really not my cup of tea. So with that said, I will try to do the very best I can to make this presentation interesting. So today I will talk about something that I have thought about for many years, refugee matching, and more explicitly how we can use different tools from market design to solve various issues and problems related to asylum seeking, related to immigration, and all these things. So my talk today will be based on a number of papers. Some of them I have written myself, and some of them are written by other people. I will not go through the entire literature. This is a growing literature that almost didn't exist a couple of years ago, but now there are many papers. So my talk will essentially be based on these 6 papers. Some of them that I have written, some of them written by others. All these papers are very good, and there is a reason why I talk about these specific papers. And because I cannot be here today, my 2 co-authors and good friends, Alexander Teitelbaum and Alessandro Martinello, will be joining you in the chat, and hopefully they will be able to answer any questions that you might have. And if you look at these papers, especially if you look at the latest version of the paper by De la Cretas, Commoners, and Teitelbaum, there is this huge reference list, and you should be able to find most relevant references related to refugee matching as of today. So with that said, let me start my presentation. So this is what made me interested in this specific problem. So I am born and I live in Sweden. And as you can see from this graph, even though the text is in Swedish, you will understand it. So these are the number of asylum seekers in Sweden between 2002 and 2018. And before the autumn of 2015, I had honestly not thought very much about matching in the refugee context. But as you can see in the autumn of 2015, what happened in Sweden was that the number of asylum seekers skyrocketed. And Sweden and many other countries in Europe faced new challenges. And this is also when I started to think about refugee matching. So what can we do as economists to do something about this situation? And I have been working with different matching problems before, like school choice and kidney exchange. So I thought, okay, so maybe we can use some of these tools. And of course, I was not the first to think about that. There were papers written long before I started to think about these topics. So it was not like I was the first one to thought about it, but I started to think about it during this refugee crisis 2015. So the point of departure for me and many other scholars in the market design field was that, I mean, you can actually see refugees and refugee matching and asylum seekers. You can see this as a bunch of different, what we call two-sided matching problems. So we know from the early literature on matching that matching theory can be a very useful tool to solve important problems in society. So, for example, we have these centralized job markets for junior doctors in the US. We have different mechanisms to allocate housing, both on campus and off-campus housing. We assign kids to public schools all over the world using techniques that we know from two-sided matching theory. So the idea was, can we think about what happened, say, in Europe in 2015 as some kind of matching problem? And the answer to that was, well, it didn't take long to figure out that the answer is yes. So, for example, you can use matching theory to assign asylum seekers to housing, because when they enter a new country, they need somewhere to live, and we need to have some kind of mechanism to figure out exactly where they should live. You can also look at it from a more global perspective. So we know that we have many resettlement programs operated by the United Nations, and you have resettlement programs within the European Union. And maybe you can see these programs as a matching mechanism. So to decide where to place these refugees. So should we send them to Norway, Sweden, or to the US? And you can maybe use matching theory as a tool to understand that type of problem. But you can also look at it on a more local level. So what happens when the refugee comes to a specific country? So should they be placed in the north, in the south, in the east, or in the west? And why should they be placed in a specific part of a country? And I will come back to this. So the general observation that others made before me was that there are many different aspects related to migration and to refugees that can be regarded as a matching problem. But this is still not a standard matching problem, because there are so many things that differs between a normal matching problem and a refugee matching problem. So, for example, if we take the example of school choice, we normally assign kids to schools one time per year. So say that they submit their applications in October or November, and then we run their applications through a centralized clearinghouse. They get their admissions in, say, March or April, and then they start school in August. So this is more or less a static problem where, one time per year we are supposed to assign kids to school. But there are much more dynamics involved in a refugee matching problem, independently what type of refugee matching problem you would like to look at. So they arrive constantly all the time. It's very difficult to predict when they arrive, from where they arrive, and how many they are. Also, the characteristics of them are also more detailed. So normally when you think about, say, school choice, we ask the parents to submit a ranking of the schools. So I prefer school A over school C over school D, and so on. But if you look at the refugee or a refugee family, they have more characteristics than the ranking. I mean, they have different education, they know different languages, they are of different age. Some of them may need some health care, some of them may need schooling, and so on. And the same thing for the localities where we want to place them. They also have multiple constraints. In the school choice problem, there's only, well, there can be more constraints, but the normal constraint is that you have these capacity constraints. So we only have 150 school seats. But if you look at the refugee matching from a municipality perspective, the municipality may have several constraints. For example, how many available seats do they have at the schools? What about healthcare and housing, capacity, and so on? And also when it comes to preferences, in school choice, if I use that as an example again, we ask parents to rank schools. So which is the most preferred school, which is the second most preferred school, and so on. But it's not clear if you would ask, say, a refugee family, so where in Europe would you like to live, in which country? And even more detailed, so suppose that you select Sweden, in which part of Sweden would you like to live? And why would you like to live there? So it's very difficult for not only for refugees, but also for host countries and municipalities to understand what their preferences are, and should we even use preferences in this problem. And when you look at it from a more technical perspective, of course, we would like to have some kind of axioms or properties of the allocation mechanism that we are designing. And it's not clear that we can use these standard axioms. So even though you can see refugee matching as, say, a two-sided matching problem, there are so many things that makes this problem different from the standard matching problems like school choice, kidney exchange, house allocation, and all these problems we know. And this is where myself and others have spent a lot of time trying to understand how to model refugee matching. And this is what my talk will be about today. Okay, so this is not a standard problem. So how can we think about refugee matching? So when I started to think about it, I was thinking about something that was very local, something I saw happen in Sweden. And I would like to give you the full background and to this paper. And I would also like to be very honest about this, that this was the first attempt to model something that very few persons had ever tried to model. So the first model we came up with, it is not very realistic, but we needed to start somewhere. And in the end, I mean, we got to talk to all important politicians in Sweden and the Swedish Migration Agency to discuss our idea. So at least this initiated some kind of discussion, even though the mechanism I will present has never been implemented in Sweden. But I will get back to that, because there is a good irony behind all this, which I will get back to when I conclude this part of the talk in, say, 15 minutes from now. So as I already revealed, my interest in this topic started in 2015 when the European refugee crisis began. So if you compare 2014 to 2015, what we saw happening was that we had more of a doubling of the number of first-time asylum seekers. And because there is really no systematic way to divide the refugees between the European Union member states, we have to rely on something known as the Dublin regulation, which I will not talk about in detail. The point I want to make clear here is that if you look at Sweden, which at that time had a population of 9.9 million people, so the population of Sweden represents roughly 1.4% of the European population. But in 2015, Sweden registered almost 1 of 8 asylum seekers, so 12.4% of all asylum seekers in the European Union was registered in Sweden. So Sweden was the state in the European Union with most asylum seekers per capita. And this is what I saw, and this is what I wanted to think more systematically about. So before I can tell you about the specific problem that we try to solve, I'd like to give you some more detailed background about the Swedish system. So a refugee that arrives to Sweden and seek asylum, they will be temporarily placed at the Migration Board accommodation facility, where they essentially wait in order to get a deportation order or to get a permanent residence permit. So if they are granted a permanent resident permit, their status will be changed from an asylum seeker to a refugee with a permanent residence permit. We call them nyanlända in Swedish. This is a technical thing which you need not care about. But this also means that they have the right to a number of different establishment measures, so accommodation, Swedish language courses, and a monthly allowance and all these things. And they all should also start needing to coordinate an establishment plan with the Swedish Employment Office. But what became essential for the problem I will describe right now is that as soon as this happens, they also have to leave this Migration Board accommodation facility, and they will be placed in the municipality. And when they are transferred to this municipality, it is up to the local municipality to find an appropriate accommodation. So municipalities have the responsibility. But if you have ever been to Sweden, or if you ever tried to live in Sweden, you will know one thing. Housing is extremely difficult. It's very difficult to find somewhere to stay. And this is exactly what happened. So in 2015, and even more so in 2016 and 2017, all accommodations options were essentially exhausted here in Sweden. So when we started to think about this, they said that, okay, so we need at least 20,000 new residential units to accommodate these refugees. And that was updated just a few months later, that they needed another 10,000 units. And what was even worse is that, I mean, there were some parts of Sweden where there was more housing, but of course we couldn't put all refugees in this specific part of Sweden. We wanted to spread them out in different parts of Sweden. And we had this new legislation coming up at that time saying that all municipalities, they have to accept a specific quota of refugees every year. And because it's up to the municipality to find housing, somehow they needed to solve that. And you could see some very constructive attempts to solve this very difficult issue. They were never used in the end, but it at least demonstrated, the kind of the problem that some municipalities was facing. So there was this passenger ship that was leased to host 800 people outside of Lund, where I live, actually not just a few kilometers in that direction. They built like this temporary camp for asylum seekers. So the problem that the municipalities was facing is that the housing opportunities were completely exhausted, but somehow they needed to take care of these refugees. And the question was then, is there some way we can fix this? So when we started to think about it, of course, I mean, the best solution would be to build new buildings, but that would be too time-consuming and probably too expensive. So when we started to think about it, we thought, okay, so we also know from statistics not only that housing is very difficult in Sweden, but we also know that many Swedes, they live in houses and apartments that are simply too big for their circumstances. And there was this survey where people was asked, would you be willing to host a refugee in your home? And roughly 1/3 of the Swedes said yes. Of course, I'm not so naive that I believe that this number is true. I never believed that, because answering yes to a question is a very different thing from actually doing it. But there are around 5 million houses in Sweden. So instead of, say, 30% saying yes, suppose that only 1% would say yes. That will mean that we will have 50,000 housing opportunities here in Sweden. And this was the observation that we made, and we thought it was important. So the idea was, we cannot construct all these new houses in such a short period of time. So what if we can ask people if they could host refugees? And if only 1% of the Swedish population would say yes, then we would at least temporarily solve this housing issue. So that was the idea. And so where is the market design in this? Well, the market design in this is that given that we would have all these, say, private persons, or what we call landlords, even though they are legally not landlords, it's more like private persons like myself and others that are willing to host refugees. So we have them on one side of the market, and on the other side of the market we have these refugees that need somewhere to live. So here you have this two-sided matching market, which is something that we recognize from the matching literature. And maybe we could do something clever about that. So this is what we came up with. So let's try to model this as a two-sided matching market. So we have one set of landlords or private persons with capacity and willingness to accommodate refugees in their private homes. And then you have this set of refugee families. The problem here is that normally when you model two-sided matching markets, you ask agents for the preferences. And I mean, it's unrealistic to ask from, say, a refugee family that they would have preferences over landlords. I mean, some of them, I mean, they've never been to the town that they were placed, or the municipality where they were placed, and they have most likely never ever met all the potential landlords, so we couldn't ask them to have preferences. But one thing we knew that it is important that you're able to communicate. because language is a key to integration. So we said, okay, so let's try to induce the preferences. So instead of asking them to report something which they couldn't report, let's try to figure out some reasonable way to structure this. So we said, okay, so let's suppose that they must have a common language with the landlord. So if we would ask the refugees to report what languages they spoke, and we ask the landlords the same thing. Some of them only speak Swedish, some of them may speak English, who knows. So we said that we would like to define a system where we can say which landlords that are acceptable for each refugee family. And this is based on two things. They must be able to communicate, so they must have at least one language in common. And the landlord must be able to accommodate all members of that family. So if it's a family of 5, we only consider assigning this family of 5 to a specific landlord if the landlord can accommodate all 5 members. We don't wish to split families. That's the key. So given this very simple structure, we could induce preferences. We could see which landlords that was acceptable for the refugees and vice versa, based on capacities and languages. And as I said, we know that language is key to get integrated into a country. There are papers that have demonstrated that, if you can communicate with people around you, it's easier to get established on the labor market and all these things. So, of course, this assumption that we made that they must have a language in common, was this a reasonable assumption or not? So we started to look at the languages spoken here in Sweden. So these are the native languages spoken in Sweden in 2012. And you can see that the native language of this population, which in 2012 was 9.6 million people, 8 million of them had Swedish as a native language. But if you look at other languages like Arabic, Kurdish, Persian, Somali, these are languages that represents more than 50% of the asylum seekers that arrived in 2015 and also later in 2016, which we didn't know at that time. So we could see that many of the languages that were spoken here in Sweden were actually languages that came from from countries where these refugees came from. So that made us kind of optimistic that we should be able to find a language match. So we continued with this project, and we constantly discussed it with the Swedish Migration Agency and municipalities, and we even went to speak to people at the Swedish Parliament about these ideas that maybe we should try to build this kind of matching system. But when you build a matching system, it's not only important to decide, how to report preferences or how to induce preferences in this case. It's also important to ask, what type of properties would we like the matching to have? So, because just finding a matching, that can be done, but is there some specific properties that we would like it to have? So after our discussion, especially with the Swedish Migration Agency, we came up with a number of different properties that we think that a good matching should have. So one of them is something known as maximality, which is essentially that we try to assign as many refugees and refugee families as possible to the private landlords. This may sound like an obvious axiom, and it is an obvious axiom, but it's not that easy to find a maximal matching. I will come back to this later on, where I will show you. I will give you some more examples about complications to have all these constraints satisfied at the same time. Another thing that we were interested in is that we would like to have an efficient outcome, which in this case means that when we're done with the matching, we don't want some landlords and some refugees ending up more happy if we would modify that allocation in some way to respect all the different capacities. So this is something known as parity efficiency, which is a standard axiom. And we're also interested in an axiom called stability. This is a hugely important axiom in matching theory. So what it means in this case is that what we don't want is that to say that we have an unmatched refugee family that strictly prefers some landlord to being unmatched, when at the same time that specific landlord strictly prefers that refugee family to the current match. Of course, when I talk about strict preferences here, I didn't give you the whole story because, I mean, just using these languages will not give like this induced preference class where you have strict and weak preferences. So we had to assume impose more structure on the preferences, which I will not talk about here, but essentially we were saying that a landlord that is willing to, say, accommodate 5 refugees, they would prefer accommodating 5 refugees to 4 refugees to 3 refugees and so on. So there are some additional structure that we need to impose here, but the essential idea is that we have these axioms which all make sense, and also the Swedish Migration Agency thought made much sense. The problem is that, I mean, it's not like if you find a matching that satisfies one of these axioms, then you get the other 2 for free. So it was kind of easy to demonstrate that even if you would have an efficient and stable matching, it's not necessarily maximum matching. And even if you would have a stable maximum matching, it's not necessarily efficient and so on. So it's not so easy to say that take an efficient matching and then you get stability and efficiency for free. You need to think more carefully about it. And we did, and we actually proposed 2 different algorithms to find matchings that are efficient, stable, and maximum. One of the algorithms didn't survive because it was very computationally inefficient. But we were able to demonstrate that if you would have this set of landlords, if you would have this set of refugee families that are being registered somewhere in the database, and if you would know the languages, and if you would know the capacities of the landlords and the size of the refugee families, then you can set up something known as a maximum weight matching problem. And if you solve that problem, you're always guaranteed to find a matching that is efficient, stable, and maximum. And we were, of course, super excited about this because we started to think about this in November 2015. And we already had all ideas ready, I think, by March or something in 2016. So that's some kind of record, at least for me. I'm a slow thinker. I need to think for many years about problems, but this went really fast. So what we didn't know at that time, but what some referees asked us to do is to think about manipulability. And of course, I mean, it feels weird to talk about manipulability and refugee matching at the same time, right? Because we will think that, you know, people are honest. And in this case, in school choice, I mean, parents try to manipulate the outcome all the time. We know this. I mean, and they do that by misrepresenting the preferences of the schools if the wrong assignment mechanism is used. So why would we even care about manipulability in the refugee matching context? And that's a very good question. But nevertheless, we know that systems that somehow can be manipulated, they will typically not survive. So it's, from an academic point of view, at least important to think about this. I will spend 2 minutes talking about manipulability here. So what is well known in the matching literature, and this has been known since the 1980s, is that if you have a two-sided matching markets, it's impossible to have stability and non-manipulability at the same time. There is always, I mean, if you would select a stable outcome, there is always one side of the market. So say either the student side or the school side that can manipulate the outcome by misrepresenting different things. Here, we need to think about what does even manipulability mean. So one way that one potentially could manipulate is by misrepresenting language, because language, as I told you, is an important criteria when we do the matching. Another thing that could be manipulated is different capacities. So from the perspective of the landlord, how many refugees he or she is willing to host. And refugee families, you could potentially think about it, if you want to do it like that, is that they can manipulate the family size by either merging two families into a larger one, claiming that they are one family, or they can split one family into two smaller families. I have no evidence that this has ever happened, so this is just for academic purposes, but what we were able to demonstrate is that a similar impossibility result. So manipulation by means of language misrepresentation is impossible for refugees, but it's possible for landlords. Capacity manipulation is not possible for landlords, but it's possible for refugee families. So landlords and refugees can manipulate in different dimensions here. And we thought that was a cool result from an academic point of view, but in reality, I understand that this is not as important as it is for us academics. So ending this part of my talk, I think the takeaways are the following. So when we started to think about this, very few people had thought about it. And you need to think about these axioms, how to define different models, how to induce preferences and things like that. So we did this with this very stylized model. And I'm not claiming that it represents reality in a very good way. But it was still relevant from policy perspective, because even though this mechanism was never, and it probably never will be implemented, at least we were able to structure a problem and think about the problem. But we're also able to share our ideas and knowledge from other problems. So I have designed school choice programs all over Sweden. I designed kidney exchange programs and auctions and all these things. So many of us that have some experience in market design, we could share that experience, and hopefully that was helpful. But the big irony of this was, of course, that when we didn't want to continue this project any longer, we saw that many municipalities in Sweden, we found at least 50 municipalities out of the 290 municipalities in Sweden, that's starting to search for private landlords to host refugee families. So our idea that we started to think about 2015 was actually implemented on not as centralized as we would like to have it, but municipalities, they actually had to do this at some point. And of course, it probably would have been better if you could do some kind of centralized mechanism behind it, but that was unfortunate. But we learned a lot, and in particular, we got very good connections up in the government. So that will be important for the next part of my talk. Okay, so let me move on to the next part of my talk. So I will now talk about a different problem. So the first problem was about house allocation. This is a problem about deciding where in a country we should place refugees to maximize the probability to get established on a labor market. So this is a project together with my great colleagues that I have. So Alessandro and Alex, they are in the chat forum right now, and then we also have Norges and Andy. And this is a paper which is forthcoming in operations research. And my colleagues have done actually most of the job, so they are the heroes. I'm just presenting it, okay? This project is super exciting because it's something that has been implemented in real life in collaboration with an organization called HIAS, the Hebrew Immigrant Aid Society. And they are also here today. So we're very excited about this project. So the project is called Anymore, and Anymore was the first immigrant recorded at Ellis Island in New York in 1892. But for the purpose of this talk, Anymore is a computer software matching and outcome optimization for refugee empowerment. And I will talk about this software. I will talk about the problems that it tries to solve. I will also talk a bit about the implementation. But let me give you the broad picture here, and I probably should have used a map from the US because it has been implemented in the US, but I will use a map from Sweden. So the key question here is that we would like to answer the following question. Where in a country should a resettled refugee or an asylum seeker be placed? And this is something that is not only relevant for organizations as HIAS, but it's also highly relevant for governments and other NGOs. Simply because we know that the initial match matters for the probability to get established on labor markets and so on, which I will talk a bit more about in a few seconds. But the problem is that when we talk about where they should be placed in order to get integrated, we should know that there is no single generally accepted definition, theorem, or model of immigrant and refugee integration. So if you would go and search that literature, you will see that there are hundreds and hundreds of different definitions of what integration actually means. It has to do with employment, housing, education, demography, social networks, health care, and so on. So there are so many different dimensions to what we mean when we speak about integration. So in this talk, we will focus about employment. And the reason for this is that we know that employment is very important for people to get established in the society, to integrate to a new society. But when it comes to employment, we also know that time and education matters. So again, I will use some Swedish numbers here, but there are two. If you look at the left-hand side first, so these are for females, and the right hand is for males. So this essentially says that how many of them had employment after a specific number of years after arriving to Sweden. So these are years. So if you take the female chart to the left, so we see that 15 years after people have arrived to Sweden, less than 40% of the females that have a low education received any type of employment. So this is the green line. So the blue line is if you have university education, and then the numbers look a bit better. So then roughly 75% of all females had some kind of employment 15 years after arriving. So employment, we know that time is important, and you can actually see a similar pattern for the males to the right here. So the point I want to make is that time matters and education matters to get employment. But we also know from research, and there are many references in our paper, I will not talk about them, is that the initial match, exactly where people are placed in a country, also matters for employment and welfare and education. So when we resettle, or when we take care of asylum seekers and put them somewhere in a country, it actually matters where they are placed for their possibility to get employment. And if they get employment, we know that that will also make them more integrated into society. So, but it matters from different perspectives. So you have the macro perspective and you have the micro perspectives. So, so regions have different characteristics. So different regions in a party have different indices structures. They have different employment rates, they have different growth and so on. But it also matters from an individual perspective. So individual refugees, asylum seekers, and resettled refugees, they have different characteristics. They have different age, they have different gender, they have different education, they have different spoken languages, they have different work experience, and so on and so on. So there are different things that decides, say, the probability that a refugee will get employment in a country. So this is just to illustrate the first point, the macro point. So this is like the growth in different parts of Sweden. in 2016. I just selected a random year. So this is an index. So 100 should be some kind of average. So you see that even in a reasonably small country like Sweden, you have different economic growth in different parts of the country. And of course, it is probably more preferable to come to a part of the country where you have a higher regional growth than to a part where you have lower regional growth. And we also know that if you take on a more micro perspective, so depending on if you have an education, what type of education you have, how old you are, and what type of work experience you have, you may have different, say, probability to get employment in different parts of the country. So this is two persons and their estimated probabilities to get employment in different regions of Sweden. So we see that it could be actually quite different between two different persons depending on their individual characteristics. I mean, there are some parts of Sweden where it looks more or less the same, but as you can see, the colors are very different. So the initial match is important, and your individual characteristics as well as the macro characteristics may influence the probability that you will get a job in the end. But this is not all, because we also know that even if you would do the experiment saying that we should assign, say, all refugees to the part of the country where we estimate that the probability that they will get employment is the highest. If we would do that, it may be the case that we will assign all refugees to very specific parts of the countries. And then we have not taken into consideration different capacities, regional capacities that are around. So for example, if you send refugee families to a specific part of, to a specific town or a specific municipality, I mean, they need to put them in schooling. And it's not clear that the schools have the capacity to host all these refugees if all of them are sent to, say, the same municipality. The same thing is that you have different inbuilt restrictions in terms of housing, healthcare, and so on. So even though ideally you would like to place refugees in parts of countries where the probability that they actually get employment is the highest, that's not feasible because you have all these different restrictions relating to schooling and housing and all these things. So this is also where Annie Moore comes in. So you have these two different things. So first you have this the desire to place refugees to maximize the probability so they get established to the labor market, because we know that that will help them to get integrated. And on the other hand, you have all these different restrictions. And I will use, this is a paper by Alex, by the way, who is sitting and listening to this, and David and Scott, which is one of the papers I listed in the very beginning of my presentation. So the paper is not published yet, but it will be published in a great journal, because this is probably, if not the most important, so at least one of the three most important papers that has ever been written in this field. So they use this TV game Tetris to explain this, and I will do the same thing. So and try to explain the idea about Annie Moore. So let me build you this Tetris kind of puzzle. So what you see in front of you now is that you have 5 families. So we call them F1 to F5. And you have 4 localities. So we call them L1 to L4. And the idea is that we can describe these families in different dimensions. So recall from the very beginning of my presentation that I said that in school choice there's typically only one dimension, but this is a very multidimensional problem. So suppose that we can describe families using this kind of Tetris blocks. So if you look at family 2, so we can say that, okay, so the yellow family, they need 2 seats in a school, and they need 1 unit of advanced healthcare. The green family, they don't have any kids, so they don't need any seats in the school, but they need 2 healthcare units and so on. And you can characterize these refugees if they have the data, which fortunately HIAS had, so we could get great data about different aspects about the needs of the refugees. We can characterize them by these multidimensional Tetris blocks. But you can do the same thing with the localities, and that's the beauty of it. So if you look at locality 1, the first bar with these 4 blocks represents the number of available schooling units. So they have 4. The other 3 localities, they have 2 schooling units, and so on. And the idea is then to try to see how can we satisfy all these capacity constraints. So this would be one way to do it. Here you see that if we would place the refugees like this, we can provide all healthcare because they all fit in this locality kind of boxes, right? So everything will be satisfied here. All our constraints are satisfied. The problem again is that exactly as in the previous problem I described, is that there is no unique solution to this problem. This is also a solution, and this is a third solution. So all these 3 solutions will make sure that all capacity constraints are satisfied. So they're all what we call feasible solutions. But if we have a set of feasible solutions, then we can start thinking about the objective, to maximize employment. So if you look at the red family here, so in this way, the red family is placed in locality 1. Here they're placed in locality 2. And the green family is also, moving around a bit, and the blue family. So what if we are smart about this? And we try to select the feasible solution of all feasible solutions that maximize the probability that these families can get employment. And this is the idea. So you play Tetris to make sure that the capacity constraints are satisfied, and then if there is more than one solution, you select the solution where you maximize the expected probability of employment. And if you want to look at the mathematics, it looks something like this. So you maximize this kind of objective, which is, as we will interpret, as the probability or the joint probability of a family to get a job if they're placed in a specific part of Sweden or the US or in any other type of country. These 1B to 1E restrictions are just these feasibility constrictions to make sure that they are placed only in one locality, that different other capacity constraints are satisfied, and so on. So the problem here is how to estimate this value function, or how to estimate the probability that they can get employment somewhere. To do this, we got data from HIAS, US data. And the idea, as I said, is to try to estimate the expected probability of employment for refugee that belongs to a specific family if they are matched with a specific locality. So for each family member, adult family member, and for each locality, we will try to estimate the probability that they can get employment. I mean, and as normally is the case, I mean, some of these refugees, they have a very high probability in all localities, and some of them have a very low probability in all localities. But that's not the point. The point is that we do this for each refugee and in each locality, and then we can try to solve this Tetris puzzle, as I said, to find the most feasible solution. So we could use to estimate this probability. We used a number of different measures. So we used gender, age, nationality, language, education level, medical conditions, and so on and so on. And we also used these macro variables. So we have individual characteristics and macro characteristics, as I told you earlier, was very important. And to estimate this, we use different machine learning approaches. So we need to have a training data where we train the machine, and in the end we would need to test it on specific data. And this data was kindly provided to us by HIAS. and I will show you the outcome later on. I will just very short say that we used two different machine learning models. So one was the LASSO and the other was this graded boosted regression tree model. And we tried them both, and the last one, the gradient boosted regression tree model, is the model that was used in this beautiful paper published in Science, which is one of the most important papers that has ever been published in this field. And it's also cited on one of my first slides. So they use this method. But when we tried both of them, we could actually see that the LASSO approach produced slightly more stable and well-calibrated predictions. So in the end, we decided to estimate the model based on LASSO. And if we did that, you could also use some counterfactual optimization considering different scenarios. So as I said before, these capacity constraints are very important. So is this like a very fixed numbers? So suppose that a specific locality, say in the US, they can host, say, 50 refugees over the next year. But suppose that there is some kind of flexibility. So must it be 50? Can it be 55? Or and so on. So we could play around a bit with this local capacity. So can we use the observed, or can we allow to say a maximum of 10% increase of that, or should it the capacity be used between 90 and 110%? So we could actually play around with this to make some kind of counterfactual analysis. And the same thing with these binary need constraints. We can turn them on and off. And family size, this is actually important. And this was not only important in HIAS, it has also been very important here in Sweden, because it's a different thing. So suppose that, say that you're assigned 10 families. It means it's a difference if you're assigned, so suppose that you should be assigned 10 refugees. So there is a difference between being assigned one family with 10 members and being assigned 10 individual refugees, because that says something about housing, potential schooling, and so on. So we were also setting these constraints about average family size for each locality. So one of them that we were very agnostic about it, say, well, it could be any type of average family size, or the observed from last year, or should it be 2.5, 3 members, and so on. So we could play around with different restrictions, and we could re-optimize, and then we could make the predictions here. So this is a table from our forthcoming papers in operations research. It is probably too small for you to read it. So, but the idea is that to the very left here, you have all these things I just described about capacities and average family size and binary service constraints on. What is important here is this thing here, because what we want to estimate in the end is if we would use this more systematic approach to assigning refugees to different localities, what is our prediction that will happen with the probability for them to get employment? And here we use a criteria employment within 90 days, which is what they use in the US. As I showed you previously, in Sweden it was 15 years, but that's a different story. So if you look more carefully about this thing that I have framed here, so the percentages to the right here represents the expected percentage increase in employment. And there are two things that two of them we can look more detailed about. So one of them is that if we have the most general constraints, so we don't have any restrictions on average family size, we turn off all the binary need constraints, capacities could be, in this interval. And then, so if you don't have to take any constraints into considerations, then we estimated that the employment rate would increase by 38%, which is huge. And this is based on then historical data and our machine learning approach. So, but if we would actually do something which is more realistic, is that we look at the observed capacities that the different that they have. We look at the observed family size, then we actually turn on these binary needs constraints. Then we estimated that employment would increase by roughly 24%. So by being a bit smarter and more systematic about where to place these refugees, we estimated that we can actually increase the employment rates by, say, 20%. And this is exactly what they found in the science paper as well. And they're also working now. I know that they're working with other countries here in Europe to implement their system. So I think this is something which it demonstrates that if we are a bit smarter about taking care of, looking more closely at the individual characteristics, looking more closely at the regional characteristics for different localities, then we can actually increase employment using these kinds of techniques. So HIAS has been using Anymore since May 2018. So they have been using it for almost 3 years now. And that was the first version, but that version has been delivered, an updated version of it a few times. And I should also mention here, and this is important, that what the Anymore does is that it will give a recommendation. So it's not like you push the button on the computer and when you're done with that, you just assign the refugees to these different localities. So it provides a recommendation, but each case needs to be individually handled and approved. And this is very important. But from what we have heard from HIAS is that they claim that they save like 20, 30, 40% of their admin time using this computer software, and then they can spend more time on the more complicated cases. So this is a screenshot about how Annie looks, essentially. I will not go it through, but it actually exists, and there is this very nice computer program. So the point I want to make here is that machine learning, integer optimization, operations research, econometric research can be applied to increase the probability of successful integration. And Anymore was the first software that did this, but it will for sure not be the last. And I hope that other organizations and that governments and NGOs around the world will start using software like Anymore, because even if it would have zero effect on employment, at least we can make sure that the different capacity constraints are satisfied, which is a huge and difficult problem to solve manually. And of course, a lot of work remains. This is only the beginning, but I have been super excited to be part of at least some of the development in this direction. So let me summarize. Just a few years ago, there was no literature on refugee matching, essentially. There were a few papers, and Alex Teitelbaum and others started to write about this. And I also think that I have made some, at least small, contributions in this field. And I have only been able to talk about 2 papers, but there are many more papers. And there are also many directions for future research. So, for example, we focused on employment here in Annie. In the first paper I discussed, we were focusing on housing. But there are other integration outcomes that may be interesting to look at as well. And also this dynamic quota management. I mean, now, essentially what we do is that we deal with this as a static problem. But in reality, of course, refugees, they come all the time. And you need to think about this more dynamically. I have a paper on that, but it's not very good. We're trying to make it much better. I also know that Alex is working on these things. What about preferences? Now we induce preferences. Is there a better way to do it? And so on. And I encourage you all to work on this, because this is a super exciting area. But you have to remember, as always, and especially if you want to implement something in real life, the devil is always in the details. So you always need to pay super much attention to all details and think hard about that. And with that note, I'd like to thank you so much for staying around with me for this last hour. And you can read, if you can read Swedish, you can read all about refugee matching in my popular science book, Algoritmmakaren. So once again, thank you so much, and I wish you a wonderful conference. Have a nice day. Thanks to the organizer. It was super cool to present it here from Lund, but of course, I wish that I could have seen you face to face, maybe next year. Bye-bye and take care, everyone.
That was quite lovely. If you don't mind, everybody, we'll record the Q&A, but I think the first thing we should do, because this is being recorded, is if you've got your camera on, give Tommy a round of applause, because that was a lovely thing to do. Fab. So thanks, and we'll share this with Tommy so he knows it was rather appreciated. I guess we should spend a couple of minutes on questions. There was loads of discussion in the chat. I mean, it seems much more active than some of the other modules. So well done. You know, we're doing well in this module. Is there anything that somebody wants to raise a hand on and kind of raise verbally, or are most things appearing? Because we will slowly transition to the panel otherwise. If you want to raise your hand, you can click reactions and then click raise hand, and then we'll try and see you and call you, unmute you.